Whew. Okay. I've literally been having the hardest time trying to get something or like find a way to record videos for you guys, but I think I'm just gonna go back to doing, recording from my phone and then uploading it to YouTube. I tried doing this cool thing with my iPad, which I can show you. Like I can go into my photos and I have a video ready to go. Just like, you can't really see it. Let me put it up here. And I'm like talking on the video and stuff, but no. I tried uploading into YouTube, did not work. It was awful. So I'm just gonna go back to doing pen and paper to teach you guys. So first of all, quarantine, this stuff is crazy, guys. I'm losing my mind being in my house all the time, but it's okay. Doing something productive like making your lessons and teaching you guys is what is keeping me sane right now. So I've just been planning a lot for you guys. Hopefully you're still able to learn and want to learn while we're here stuck at home. I don't know what the probability of us actually going back to school is. It's really, really low. But, we're just going to have to make the best of this situation and work together to find a way to get you guys to finish the school year via the internet. So with that being said, I hope you guys are doing good. I'm sure you're loving your time at home. Not really doing much. However, I do know that it gets boring sometimes. So take a minute if you haven't done so today or once a week. Go outside and run, go exercise, go breathe some fresh air instead of being cooped in your house or in your bedroom all the time. I know y'all are teenagers. You love to lay on your bed, be on your phones all the time. Put the phone away. Take some time to go outside and, do something that you normally wouldn't do during this time, because I know you get bored of one thing and you're like, I don't know what there is to do. Just think of something. All right, anyway, I'm gonna go ahead and start with the lesson. I know a lot of you guys, I got a lot of messages saying, I don't know what was going on in those Khan Academy videos. It was very confusing. I'm gonna go ahead and break it down for you. So I did start rotational motion with my A days. My B days, I might have started just like very briefly. I don't remember. It was so long ago. It was like 4 or 5 weeks ago. But my A days, I know we started making like a little study guide booklet that was supposed to help you guys organize all your thoughts and all the stuff that I was saying in detail. So I'm not going to make a booklet. I'm not going to make you guys make a booklet because for what, we're going to do everything online. But I am going to make these videos to help you all better understand what is going on in the Khan Academy videos. So I watch them and I do understand how they can get confusing. The guy who makes the videos uses a lot of like very intricate terminology that I don't expect you guys to know yet because I haven't gone over stuff. But that's why I'm making these videos for you. I'm going to water it down a little bit. I'm going to go through the same content that that they went through on the Khan Academy videos. I'm just going to go off the PowerPoints that I was going to show you guys. So I'm going to go ahead and get started. So we're going to be talking about rotational motion. So we already went over a chapter that was very similar to rotational motion. We talked about circular motion, where things spin in circles, right? Okay, this is kind of the same thing. The difference between these two, basically, when we talk about the content in each chapter, is this gave you the basic things as to reasons why objects move in circles and continued to move in circles. This gives you more detail as to what we can measure while things move in circles. So rotational motion is pretty much the study of an object moving about an axis. So something like our globe on its tilted axis right here. I'm gonna go ahead and draw the continents, Africa, Asia, whatever, United States. So here is the axis. So pretty much what you guys learned in like 7th grade or 6th grade was like the axis is an imaginary line from which the world revolves around, right? So we know that every time the earth spins on its axis, one full revolution is equal to a day, right? And then apart from that axis, the earth spins around the sun. And we know that one full revolution around the sun is equal to 365 days or a year. Okay, so pretty much we're just going to be studying things that are revolving around an imaginary axis just like this. Some of them may actually have real axes that they revolve around. But in the case of Earth, we're going to just talk about that imaginary line that's there. Okay, so what I really wanted to go over today, the most important thing is rotational motion and how it relates to kinematics, because I know one of the Khan Academy videos went over that and it probably confused the heck out of you guys. So I hope I didn't stain this super now. Okay. So let me try and move this paper up so you can see everything. Let me go over kinematics really briefly. So we're taking it back to chapter 1 when we first did this stuff at the very beginning of the year. So kinematics, pretty much the study of motion, how things move, why they move, what we can measure from their movement. We talked about 5 kinematic variables. Delta X, you guys remember this is displacement. We have VI, VF, initial and final velocity. We have acceleration. And let me move this up a little bit so you can see the last one. And we have time. So these things were really, really, really important to us when we talked about kinematics in chapter 1. Now, this is almost going to be mirrored exactly when we talk about rotational motion. So in rotational motion, we have what we call angular kinematics. Okay, so pretty much going to be the exact same thing as kinematics. However, the variables are going to be switched up a little bit into some weird Greek letters. So what I'm going to do to make this easier for you guys is I'm going to make a chart. My A-days, you may have this in your notebook already. If you do, just go ahead and follow along with what I'm doing. So this side is going to be linear. This side is going to be rotational. Okay, so linear, this is just going to be the regular kinematics that I just talked about right now before I moved on to this. So the first variable I'm going to go over is going to be delta x. So this we know as linear displacement. Okay, so I'm going to go ahead and write displacement on the side just so you know what I'm talking about. The rotational counterpart for displacement, which I'll write on the side as well, just so you know that this is also going to be displacement. However, this is going to be rotational or angular. I'm going to write that at the top. This variable is going to be called theta, which you guys should already be familiar with this, right? Whenever we talk about theta, we talk about measuring the angle of something. Okay, so this is theta. The second one, VI. This is initial velocity. You guys should know that. I'm not going to write it on the side. This is initial velocity. The rotational counterpart is going to be this variable that we call omega. Looks like the Walgreens sign or the Walgreens symbol or the Washington Nationals for those of you guys who follow up with baseball. Omega I. Okay. Now VF is going to be the exact same thing. We're going to have omega still, except we're going to have that little F attached to it. And I left a lot of space for these too. So acceleration's counterpart is going to be called alpha. Looks like a little weird fish. So that is alpha. I should probably write these on the side. This is theta, omega, alpha, and then the last one is time. And time stays the same on both sides because it is a scalar quantity. So I'm gonna go over the units for each of these at the bottom here. So delta x, we measure in meters. Theta, we're gonna measure in angles. No, we're not gonna measure in angles, I was just kidding. Angles are not a unit of measurement, but we do have a unit of measurement for the angle. Some of you guys may be thinking degrees. We've been using degrees so far up to this point. However, we're going to switch it for rotational motion. Here, we're going to be using the radian. So those of you who have a calculator with you, please go ahead and switch your calculators to radians instead of degrees on this chapter. You should be able to go to mode, and then one of the numbers should have degrees radians. You just go ahead and switch it to radians. So we measure our angle theta in units of radians, okay? We measure VI and VF in units of meters per second. We measure omega I and omega F in units of radians per second. Okay, we also measure acceleration in meters per second squared. Here we're just going to go ahead and translate. Alpha is going to be measured in units of radians per second squared. And then the time's going to stay the same. They're all measured in seconds because time is a scalar quantity. Okay, now last thing I want to go over before I end the video is going to be equations that we're going to use for each of these. So for displacement, we're going to have theta is equal to S over R. So let me go ahead and explain this formula really quick for theta. I'm going to write formulas up here. So you guys don't know what S is yet, but I'm going to go ahead and explain. So when we have a circle and the axis is here in the middle, an object, let's say that an object starts out here, position, I'm going to put position 1. And it moves this way, so we're moving counterclockwise to position 2 over here. I moved from being right here to right here. And I covered some distance equal to this. This, let me see if I have a highlighter. I do. This, some of you guys may remember from, I think you did this in like Algebra 2 or Pre-Cal. This is called the arc length. So this is pretty much, the arc length is the distance that's going to be covered in going from position 1 to position 2. And this is what is S. Okay, and R is just going to be your radius. We've gone over that before. So the way you calculate the angle theta in between here is dividing this arc length by the radius right here. And that's why we have this formula for theta over here. Now the formula to get omega, let me check the PowerPoint really quick. We get our angular velocity, omega, by dividing the change in our angle over the change in time. So this is going to be the second formula that you need, omega. The third formula is going to be for alpha, and it's just going to be your change in velocity over your change in time. And these are the three formulas you need to know. Now I will be uploading a couple more videos. I just don't want to make them too long to where you guys get bored. I think I'm going to do 3 parts for this particular part of rotational